So in this video, I'm going to talk about how to do partial fraction expansion. So as you probably already know, partial fraction expansion is when we've got some multiplication of fractions. So like 1 over x times 1 over, let's say, x plus 1. And we want to decompose this into two separate fractions. One involving a 1 over x and one involving an 1 over x plus 1. And up top, we've got these sort of unknown coefficients. We don't know what they are, but they're what we want to find. So how do we go about finding them? Well, I'm actually going to rewrite this so that we've got these things on the left-hand side, and this will make it a little more intuitive as to how we go about doing this. So we know that a over x, we don't know what a and b are again, so a over x plus b over x plus 1 is equal to 1 over x times 1 over x plus 1. Now what we want to do is we want to get this a by itself and we want to get this b by itself. So we want a set of equations that gets a and b by themselves. And how do we do this? Well, if you just look at this term, how would we get a by itself from this equation? Well, one of the steps is definitely going to be multiplication by x, right? So if we multiply a over x by x, then we just get a. So we can multiply this whole equation on both sides by x. And let me just write that in a different color. So we're multiplying everything by x. So a over x times x plus b times x over x plus 1 is equal to now x over x times 1 over x plus 1. And that's interesting. So these x's cancel, and we're left with a plus bx over x plus 1 is equal to 1 over x plus 1. And this is interesting. You might just say, well, Jordan, you've just complicated things. Now we've got this really ugly term here, and we've got a by itself, but now what do we do? Well, we can do something, we can kind of cheat a little bit. Because if we take the limit of both sides, so what we want to do basically is we want this x here to become 0. We want this term to go away. And so if we take the limit as x approaches 0 on both sides, so limit as x approaches 0, that doesn't change the equality. So the two sides of the equation are still going to be equal to each other, but we get rid of this term. And so if we carry out the limit, you'll see that a is just equal to the limit as x approaches 0 times 1 over x plus 1, which is just plug in 0 here, which is just 1. So we've got our coefficient a. That's great. So we can do this. We can do the same exact process where we basically try to get this variable or one of these variables by themselves, and then we take a limit. And so this is a general sort of easy to remember process that works for these partial fractions that you encounter. So if we just do this again for b, well, we want to multiply everything now by x plus 1, right? Because that will get b by itself. So then we've got a times x plus 1 divided by x plus b is equal to 1 over x times x plus 1 over x plus 1. And then this x plus 1 goes away. I'm just going to erase that real quick. I did not mean to erase that 1. And now we just look at this equation. How do we get rid of this term? Well, we want to plug in x is equal to -1. So we just take the limit on both sides as x approaches -1. And that gets rid of this term. And then if we just plug in x is equal to -1 on this side, because that's here just the same as taking the limit, then we just get that b is equal to 1 over -1, which is just -1. So we've got now our two coefficients, a and b. So if we wanted to rewrite this original expression, we know that now this is a is equal to 1. So it's just 1 over x minus 1 over x plus 1. And this is our answer. And I really like this method because we don't have to remember anything. We don't have to remember anything. What we're trying to do is just get each variable by itself. So get A, B, C by themselves, and then use a limit to get rid of everything else. And so this is great because it's just a general kind of heuristic process. You can sort of figure it out as you go along. So I hope you enjoyed the video. If you did, please like and comment below, and I'll see you next time. Thanks.